Good morning, everyone. My name is Roberto Sassu. I'm a co-maintainer of the Linux integrity subsystem in the kernel. And today I would like to present my journey on implementing the IMA measurement in user space. And first, I will give you some updates on the status of Linux integrity subsystem in the kernel. Then I will introduce my work called alt IMA. And finally, I will show how we can contribute this work into the Linux IMA. So first, some highlight in the kernel, and the first patch set I would like to mention is a patch set for kexec, and which allow to solve a problem with desynchronization between the TPM and the IMA measurement list. And this has been solved by Stephen Chen from Microsoft and Tushar Sugandhi, and with the help of Baukan He from Red Hat. And the solution was to defer copying the measurement list only after the TPM operation had been suspended, so this desynchronization does not happen anymore. As part of this work, Stephen Chen also added two new critical data record into the measurement list. And also MIMI upstreamed an exception for disabling IMA only for the kdump kernel, because it is not needed. The job of the kdump kernel is only to create a snapshot of the memory of the primary kernel. MIMI also did a patch set to limit the number of integrity violations, and this issue occurred, for example, with the systemd journal, where there is a periodic concurrent operation read and write, and this was causing the measurement list to grow significantly over the time. And this problem now has been mitigated very well. Also, there is a performance improvement from Frederick Lawler, and this improvement is to avoid to take the inode lock when it is already clear that IMA is not going to process the file. This information are immutable, so they don't require a lock in order to make a decision. So this is also a nice improvement. I fixed a bug in the appraisal, basically when there is a new file, and I tried to also modify the metadata while the file is still open. At some point the file cannot be accessed, and this is caused by a flag that should not have been cleared, a flag for new file. So I prevented this flag to be cleared, and now also the file can be still open while can be still accessed while before the security.ima extend attribute is written to the disk. Finally, Alviro did some improvement for security FS, and in particular, for example, we removed the code to remove the regular file from the security FS directory that we create for IMA. And the reason is that when the function that deletes the directory also takes with them also the regular file that are inside it, so there is no need to do it in IMA. And finally, so IMA also has the capability to print the measurement list with different algorithms, and the performance the improvement was to store which algorithm we want to use to print the measurement list directly in the iPrivate field of the inode, so that it can be easily retrieved. Now let's move to user space. We are pleased to announce that IMA-IVM utils v1.7.0 will be released in September, and the main highlights are so now we separate the kernel test from the IMA-IVM utils self-test, and the reason is that the kernel tests are kernel specific and require, for example, the private key to be available. And this, for example, does not happen when the production kernel is tested. So in this case, we only execute the IMA-IVM utils self-test and not the kernel test. Also, there is I developed a new test for this appraisal bug fix that I just mentioned before, and there are CI improvements. So we want to reduce the workload for accepting patches, and MIMI integrated the kernel script check patch to check the patch format during the pull request. There are also new test dependency, and fix foresaid done by Mimi. Mimi and Ken also did some additional fix to solve some compilation warning. And finally, Henrik Uhrenfeld added the ability to handle a list of files for several AVM-CTL command. So now I move to my work. It's called Alt-IMA, which stands for Alternative IMA. It's a company project that is released under the dual license model in order for me to contribute to the Linux kernel, and at the same time we can reuse internally in the company. And it is completely rewritten from scratch IMA-measure implementation, which is 99% compatible with Linux IMA. So from the external point of view, it looks exactly like, almost exactly like IMA, with the exception that, for example, we don't support the old IMA template and neither SHA-1. In the future, I also plan to add appraisal and audit capability to Alt-IMA. So this has been developed in user space due to the nature of the project. And there are some advantages for that. For example, it's also much easier to debug, and also the code can pass through some formal verification. So now the highlights. So since I implemented the code from scratch, I already took into consideration some improvement that I was thinking while working on the Linux IMA. And in this talk, I will not fully present the Alt-IMA feature, but I extracted some few capabilities that are good candidates for being ported to Linux IMA. And in particular, I would like to talk to you about how to address the measurement list memory fragmentation, how to verify the measurement capability, and an advanced debug and testing technique. So Alt-IMA comes with a design and implementation document, and also has been developed with a test-driven approach. So for every functionality, this has been consolidated by doing some testing and then moving to the next feature. So let's talk about how to address the measurement list memory fragmentation. This is particularly important for the kexec functionality. So in kexec, IMA is scoping the measurement list from the primary kernel to the secondary kernel. And what you can see here are the steps that are necessary to do this copy. And you can see that there are many steps involved. And the main cause is the fragmentation of how the measurement list is stored in the memory. So there is a single pointer for each type of information. For example, the digest is stored in a pointer, the file path is stored in another pointer, and what the IMA needs to do is to first marshal all this information together in a blob and copy in a memory reserved for kexec. When the kexec is executed, then IMA in the secondary kernel do the opposite, do the marshalling and then recreate this measurement list structure with the fragmented pointers. So now the way I solved it is to say, okay, so we need to do marshalling. Let's do it already when we create the measurement. So we create a measurement, and we already did make it compact in a blob. So when we do the kexec, the only operation now that needs to be done is to copy this blob, which we don't need to parse, to the memory reserved for kexec, and on the opposite side we need to do the opposite operation to copy from the memory reserved for kexec to the memory of the secondary kernel. So it's already much better than doing marshalling and marshalling, but we can do even better. So there is another improvement done by Chen-Yuan Liun and Mike Rappaport to share memory between the primary kernel and the secondary kernel. And if you use this feature, basically nothing needs to be done. So the primary kernel created the measurement list directly in this shared memory. And when there is a kexec, the IMA in the secondary kernel continues to populate the measurement list from the point the primary kernel stopped. Okay, so this is the first feature. Now the second feature, how to verify the measurement functionality. So in order to do testing, it's necessary to define when IMA behaves correctly. And the answer that I try to give is that the file content should not change between the time of measurement and the file close. And the reason is that when we measure file, I want to be sure that what is measured is what the process accessed, because otherwise maybe there are changes which are not reported but cause a process to be corrupted. So if so IMA is not doing access control, so IMA let operation to be done. So if there is, for example, a change, so a process opens a file and there is a concurrent write, IMA is not preventing it, but is limit itself to report this event in the measurement list. And this measurement entry is called the violation. There are two of them. So the first violation is called time of measure, which occurs when there is a new open for write, but the file was already open for read and was already measured. The second type of violation is called open writer. So there is a new open which for which the policies say, okay, this file needs to be measured, but it cannot be measured reliably because there are already writers which are operating concurrently modifying the file. So IMA could not take a stable measurement of this file. Okay, so we want to test that IMA behaves correctly. So the first thing that, so this boils down basically in saying, okay, IMA correctly miss violation when there is this concurrency between processes, or should not emit MVO violation when everything is good, so when there is no concurrency. So what I did is to create a simple system model to represent the file content, in order to express when, for example, the file content does not change. Then I implemented a user space verification tool, which include the alt-IMA code, and looks like a minimal OS, where basically we are doing fuzzing of alt-IMA, and alt-IMA thinks that is a kernel, but in fact is a tool which is simulating what the kernel is doing, like the node, file descriptor, incrementing the write counter, etc. And so we are testing alt-IMA as a black box. So we are fuzzing it and see what alt-IMA provides, and we are seeing, okay, this behavior is correct, this behavior is not correct. And we verified this with some assertion that I will explain later. So we start fuzzing IMA. If the assertions are true, the tool continues running. If the assertions are invalid, like for example when you write a program in C, the program terminates, or the error is transmitted to user space. Okay, there is some problem in IMA that needs to be debugged. It's not a formal verification tool because it does not guarantee that all the cases has been checked. So it just does a best effort. The more you leave, the more it's likely that it finds an issue. But if it doesn't, there is some good degree of confidence. Okay, model for testing. We could have used the real file content, but I think for the purpose of testing, we want something more simple. And what we used, we represent the file content with just a counter, a monotonic counter. So whenever, for example, we want to read this file, the read is just the read of the counter. When we write, we just increment the counter. So it's easy to compare the two numbers. And so in this minimal OS that I developed, the user space processes are modeled with a thread, and the kernel and the alt-IMA code are modeled with a library that is called by the individual threads. So now we are ready to see the architecture of this tool. So we start from the bottom, where we have the main thread, which contains an inode that is shared among all these threads. So the main thread is responsible to start all the child thread, which represent the process. And each thread has a code to randomly issue an emulated system call, for example, open and map and close, which are also of interest of IMA. And each thread has a fixed array of file descriptors which refer all to the same node. So what we want to do is to stress IMA with some operations that are done on the same node, but from many threads. For example, I tested IMA with 200 threads run in concurrency. So this thread decide, okay, I want to do an open with a random open mask or random file protection, and then this emulated system call is passed to this emulated kernel and alt-IMA and verification as a library. And we can look into that. So now the first thing is that, okay, the kernel normally what it does, if it is a write, it increments the I-write count in the node, so we do the same. And then we call alt-IMA similar to what the security framework will do for each LSM. So alt-IMA do its own procedure, check if there is a violation, this concurrency between read and write from processes, and decide if it needs to do a measurement and calculate the digest and add the measurement to the measurement list. The last two parts are in blue because I modified them, so we are not dealing anymore with the file content, but because we are using this simplified model, alt-IMA deal with just with a counter. And finally, so we incremented the inode counter if it is a write, because this was part of the model. And now we store the current value of the inode counter in the file descriptor that was used for the system call. So when we pass to the close, what we do now is to check, is the counter in the file descriptor equal to the current value of the counter in the node? If yes, okay, the file content didn't change. So we are in this situation where okay, the measurement is reliable. But if the two values don't match, IMA should have emitted a violation. So we want to verify this. This is the assertion that we are verifying. And finally, the close system call alt-IMA to recheck for violation, because, for example, okay, there is one writer that is going away, so maybe the condition for which the violation was generated is not true anymore. So alt-IMA has this concept of starting a violation or ending a violation. So now it's safe again to take measurement of the file. Okay, now we do the verification of the assertion, so we check if the IMA behavior is correct, and we go from the first case. So the first case, there is an open for read, so the counter, inode counter is 0, we store in the file descriptor, and when we close, the counter is still 0, because there was no write involved, so the counter is still the same. And we check also what alt-IMA produces, this fake measurement list which contains the counter, all the value match, everything is perfect. So now in the bottom we first open the file for read, and then there is a concurrent open for write, which as I mentioned before, it causes this time of use, time of measurement violation. So initially the counter is 0, we store this value in the file descriptor, but then there is a write and the counter goes to 1. So, and we check, so the writer goes away, and now we go to the last, to the close of the original, the first open. And now we see, in the file descriptor, the counter was 0, but now the counter is 1. But if we look in the measurement list, IMA now said that there is a violation, so this IMA behaved correctly. Okay, so these are when the alt-IMA works and the verification tool keep running, so there are really many iterations. So now this part is when the alt-IMA code does not work. So we first open the file for read-write, then we open for write, and in this case IMA does not emit any violation. So we are in the file descriptor, the counter is 0, then becomes 1 because of the write. And when the first file descriptor is closed, we see that the counter, they don't match, but at the same time, IMA didn't report a violation. So this is when IMA is not working. And with this tool, I was able to identify some fixes that we need to add to IMA. So, for example, the first is this iRead counter in the node only represented the read-only, the reader which opened for read-only, not read-write. And we need or to change read count to take in consideration the read write, but maybe this is not possible because this counter is used also for locking, I think. But we can also use another private counter that is maintained for IMA in order to achieve the same result. Second, we need to, there are two critical regions in IMA for the measurement. First, we take the node lock for reporting a violation, and then there is another critical region for taking the measurement. And in order for IMA to work correctly, we need to have to merge these two critical section in one. And finally, we also need to detect the violation for write-only open because it is permitted by the policy. So we need to support also this case. So last feature, I would like to introduce an advanced debugging and testing technique that I use for Altima. And now we are not so this is not the IUSE space verification tool, but it is the real code in the OS. So when we do testing, for example, of IMA, the problem is that we load a policy, we start to take measurement, and the problem is that we cannot clear the state. So the only thing that we need to do another test is to reboot the kernel. Partially, in IMA-measurement, we mitigated this issue by using the UML kernel, so which is basically a process. So we started this kernel process as many times as we want, but it's still slow. And a solution will be the ability to reset the IMA state from user space directly to the kernel. And so this is actually what I'm proposing. So there is a process called the IMA debugger, which takes commands from, for example, from a file if it is in batch mode, or directly from the user. And this IMA debugger can send commands to the kernel, init default to initialize the IMA to the default setting, for example, from the kernel configuration. Then we can send commands, for example, IMA policy or IMA template to define the boot policy on which measurement list format we want. And then we have activate to activate IMA. So IMA will start to collect measurement and deactivate to deactivate IMA. So to turn off IMA basically. And with these commands, we can implement this circular life cycle that can be repeated as many times as we want. So the first phase is initialization with the init default command. Then is the configuration phase where we set up what we want IMA to do. Then we activate IMA and we switch to the use phase where we can load a policy, we can read do file operation, read the measurement list, and finally we do the activation. And this life cycle, this capability helps to implement test case in a very simple way. And here I can show. So on the top is the list of commands that we want to send from user space from the IMA debugger to the kernel. So first we initialize the IMA to the default value. Then here also I use a fake TPM to make IMA believe that is extending the TPM while it is a software that is simulating the TPM operation. And this because, for example, I can have different PCR banks. I can change the PCR banks to test IMA in different situations. Then I set the file algorithm to SHA-256, activate IMA, and I load a policy to measure a file open, and then I open a file and I read the measurements. Now I execute IMA debugger with this list of commands, and what it does is to print the IMA measurement list with a measurement of the file 0. And the test case here is, okay, I compare the file digest calculated by IMA with the file digest calculated by SHA-256, and if they match, the test is successful. But many tests can be done with this approach. So in conclusion, implementing IMA from scratch was a good opportunity to test fundamental feature in isolation, and so there is a very detailed design implementation document which will be helpful to explain the feature that will be ported from Alt IMA to Linux IMA, and I hope that the new debugging and testing technique will make the workload for the maintainer less heavy. And next step, so I will publish Alt IMA in forms of kernel patches together with a design and implementation document. I will port the Alt IMA feature to the Linux IMA in the upcoming months, and also we plan to combine this improve the Linux IMA kexec capability with the Mike Rappaport and the Chan Yuan Liu further improvement. Thank you for your attention.
Questions?
Hi. Thank you for the interesting talk. So if I understand it right, the main motivation was to have easier testing and debugging for IMA, right? Mm-hmm. And I was wondering if you could achieve something not similar, but maybe something kind of similar using eBPF and using kind of kernel hooks to test the regular IMA without the re-implementation part?
It is possible, but there are a lot of constraints. For example, one of the problems was that you cannot deactivate IMA right away. And the reason is that so IMA is designed to shut down, to turn off only at shutdown. And the problem is that there might be measurements which are made by IMA when you do the activation. So there will be like a locking problem, inconsistency problem, which could cause IMA to crash, for example. So this is why, yes, with the BPF, maybe it's possible, even if there is no implementation of IMA currently in the BPF. But one of the point of this tool is to use this restriction in order to make sure that you can still debug IMA and the kernel does not crash. This is very important. So it's a synergy between the tool and the Alt IMA code. But it would be an interesting extension if that is possible.
Thank you.
No problem.
Any other questions? Once. Okay, looks like everyone wants for a break. So then let's thank Roberto once more.
Thank you.